Hi, the information explained in this video is a simplification and extrapolation of the actual ARP determination process. Although conceptually accurate, the actual process is slightly different and more complex. However, for the purposes of this curriculum, the explanation contained in this section provides a good basis of understanding. In this video we are going to cover Address Resolution Protocol or ARP. ARP, or Address Resolution Protocol, is a network protocol used to find out the hardware address, or MAC address, of a device from an IP address. It is used when a device wants to communicate with some other device on a local network. The sending device uses ARP process to translate IP addresses to MAC addresses. The device sends an ARP request message containing the IP address of the remote device. All devices on a local network segment see the ARP request message, but only the device that has that IP address responds with the ARP reply message containing its MAC address. The sending device now has enough information to send the packet to the receiving device. Devices, hosts, routers, servers, etc. use IP addresses to reach other devices within their own network or across different networks. Layer 3 addresses such as IP address, which include an original source address of the sending device and the final destination address of the intended recipient. Data link addresses, such as Ethernet MAC addresses, are used to get the IP packet from one hop to the next hop within the same network. If the sender and the receiver are on different networks or different subnets, the data link address in the data link frame will be modified to reflect the new data link address source and data link address destination. Always remember, the IP address of source device and destination device do not ever change. Generally, when you assign an IP address to a device, there are three major elements needed to fill: IP address of the device, subnet mask of the IP address, and the gateway IP address. Now the question is, what information does the IP address and subnet mask provide for this host? As soon as you try to reach another device, the sender device performs the AND operation. By doing the AND operation, it tells the host what network it belongs to. Either you are trying to reach a device within the network or the device which is in a different network. In both scenarios, the sender device performs AND operation. What is the ARP process? In step 1, when a source device wants to communicate with another device, the source device checks its Address Resolution Protocol, or ARP cache, to find whether it already has a resolved MAC address of the destination device. If it is there, it will use that MAC address for communication. To view your local Address Resolution Protocol, or ARP cache, use command prompt and type command ARPA. The ARP table maintains IP address to MAC address mappings. Every device that participates in Ethernet and IP, the device will have such a table, including hosts and routers. In step 2, if ARP resolution is not there in local cache, the source machine will generate an Address Resolution Protocol or ARP request message. It puts its own data link layer address as the sender MAC address and its own IP address as the sender protocol address. It fills the destination IP address as the target protocol address. The target hardware address will be left blank since the machine is trying to find target hardware address. In step 3, the source device broadcasts the ARP request message to the local network. In step 4, the message is received by each device on the local network, since it is a broadcast. Each device compares the target protocol address with its own IP address. Those who do not match will drop the packet without any action. In step 5, when the targeted device checks the target protocol address, it will find a match and will generate an ARP reply message. It takes the sender hardware address and the sender protocol address fields from the ARP request message and uses these values for the targeted hardware address and targeted protocol address of the reply message. In step 6, the destination device will update its ARP cache since it needs to contact the sender machine soon. In step 7, destination device sends the ARP reply message and it will not be a broadcast but a unicast. In step 8, the source machine will process the ARP reply from the destination. It stores the sender hardware address as the layer 2 address of the destination. In step 9, the source machine will update its ARP cache with the sender hardware address and sender protocol address it received from the ARP reply message. Now that you understand the general process, let me bring the design and explain it again. We can explain ARP operation in some basic steps. Here, for the explanation of ARP operation, we will use an example. Think about that. PC1 wants to ping PC5. First, it checks its ARP table or ARP cache and tries to find a PC5's MAC address there. At the beginning, the ARP table of PC1 is empty and it does not contain PC5's MAC address. PC1 only knows the IP address of PC5. PC1 sends an ARP request message to the network as a broadcast message. This ARP request is sent to all the nodes in the network. The meaning of this ARP request is which host has IP address 192.168.0.5. This ARP request message consists of source IP address and destination IP address, source MAC address, and operation code. The destination MAC is written as zeros, which means the destination MAC address is requested. In the layer 2 header of this message, the destination MAC is broadcast MAC address. With this, all the PCs will receive the ARP request. However, the ARP request message will be discarded by most of the PCs if it is not intended for it. In our scenario, PC2, PC3, and PC4 will discard the ARP request message as this ARP request message is not intended for them. PC5 receives the same frame and checks the details of the layer 2 header. It observes that it is a broadcast frame, but still does not recognize whether this frame is for it or not. Now PC5 removes the header and trailer from the frame. Once PC5 notices that the ARP packet contains the IP address of the PC5, the PC5 prepares the ARP reply message for PC1. PC5 sends this ARP reply message directly to PC1. This ARP reply is a direct message to PC1. Let's understand the address resolution protocol message format. First is hardware type. The hardware type field in the ARP message specifies the type of hardware used for the local network transmitting the ARP message. Ethernet is the common hardware type, and the value for Ethernet is 1. The size of this field is 2 bytes. Second is protocol type. In this field, each protocol is assigned with a number used. IP version 4 has an assigned 2048 number. Third is hardware address length. Hardware address length in the ARP message is length in bytes of a MAC address. Ethernet MAC addresses are 6 bytes long. Fourth is protocol address length, length in bytes of an IP address. IP addresses are 4 bytes long. Next is opcode. The opcode field in the ARP message specifies the nature of the ARP message. Code 1 for ARP request and code 2 is for ARP reply. Next is sender hardware address. This field is reserved for layer 2 address or MAC address of the device sending the message. Next is sender protocol address. This field is reserved for the protocol address or IP address of the device sending the message. Next is target hardware address. This field is reserved for layer 2 address or MAC address of the intended receiver. This field is ignored in requests. Next is target protocol address. This field is reserved for the protocol address or IP address of the intended receiver. This process generally works when sender and receiver devices are in the same network. But how does the sending host know if the source IP address and destination IP address are not from the same network? Remember, I was talking about AND gate operation to validate whether the destination device is a member of the same network or different network. Let's see how AND gate helps here. The AND operation on the host IP address and subnet mask tells the host what network it belongs to. This gate is a logic gate that accepts either 2 or more inputs and shows the result as a single output. When both the inputs are at logic 0, then the output is also logic 0, and when both the inputs are at logic 1, then the output is also logic 1. The functionality is the same even if the gate has either 2 inputs, 3 inputs, and more. The AND gate rules are based on the operation of logical multiplication. To have a clear understanding, let us know how it performs corresponding to its inputs. Consider there are 2 binary inputs, 0 and 1. as the operation is based on binary multiplication. So, when 0 is multiplied by 0, or 0 is multiplied by 1, or 1 is multiplied by 0, the output is 0. And when 1 is multiplied by 1, the output is 1. In this scenario, both the devices are in the same network. By doing ARP operation, there are no binary changes in the first 3 octets. It does not matter if there are binary changes in the 4th octet. In the second scenario, both the devices are on different networks. By doing the AND operation, the 3rd octet notices binary changes, and due to this, the device recognizes the IP address does not belong to the same network. Hence, the IP address of the default gateway must be known by the sending host in order to communicate with devices outside its own network. Now the PC will send the ARP request packet to the gateway IP address to communicate with the other network device. The router checks the target protocol address, it will find a match, and will generate an ARP reply message. It takes the sender hardware address and the sender protocol address fields from the ARP request message and uses these values for the targeted hardware address and targeted protocol address of the reply message. PC1 receives the ARP reply and enters router's IP address and MAC address into its ARP table. The PC now has all it needs to encapsulate the IP packet into the Ethernet frame and send that packet to the router. It is now up to router A to forward the packet onward. That's it in this class. See you in the next class. Bye.